Hello everyone, welcome to my second video on solutions of class 12th ISC Board chapter number 14th exercise 14.1. So in this video, we would be doing solutions for question number 11 to question number 28. So let's start. Now in this question, we need to integrate sine square x into cos x into dx. Okay, so what I can do here is, I can suppose sin x to be a variable and the differentiation of sin x would give me cos x. Okay, so let's start. So let's assume sin x is equals to t. Okay, so when I'll differentiate to find the value of dx, okay, I'll get cos x is equals to dt by dx. Or I can say the value of dx is equals to dt upon cos x. Okay, now what I'll do is, I'll put the values back in the question. So what I'll get is, see, I can put sine square x as t square, right? Okay. And cos x. Cos x I'll put as it is, and dx I'll put dt upon cos x. Okay, so I'll get t square into dt. I'll integrate this t square function. So what it would be? T square plus 2 plus 1 upon 2 plus 1 and plus c. That is equals to t cube by 3 plus c. Now I'll substitute the value of t again. T is equals to what? Sin x. Okay. So it would be sin cube x upon 3 plus c. So this is the required answer for this particular question. Now in this question, I need to integrate sin inverse x whole cube upon under root 1 plus x square into dx. Now we know that the differentiation of sin inverse x will give us 1 upon under root 1 plus x square. So here what we can do is, we can put sin inverse x is equals to t. Okay, now again what I'll do is, I'll differentiate both the sides to get the value of dx. Okay, so let's do it. So we know that the differentiation of sin inverse x is equals to 1 upon under root 1 plus x square. Okay, so it will give me 1 upon 1 plus x square is equals to dt upon dx, or I can say dx is equals to dt into under root 1 plus x square. Okay, fine. Now I'll put the values in the question again. So what I'll get is, see, sin inverse x is, I can keep it as t cube, right? And under root 1 plus x square I'm keeping as it is. And the value of dx is equals to under root 1 plus x square into dt. Okay, so both the values will get deducted. Now what I need to do is, I need to integrate t cube into dt. So that is equals to t 3 plus 1 upon 3 plus 1 and plus c. Okay, so the final answer would be 4 plus c. What I'll do is, I'll substitute the value of t again. That is equals to sine inverse x raised to power 4 upon 4 plus c. So this is the answer for question number 12. Now in this question, I need to integrate sec raised to power 4x into 10x into dx. Now here, if you substitute 10x is equals to u or t, I'll get sec square x as differentiation. If I substitute sec x as a variable, I get sec x into 10x. So we can do via any method. Okay. So what I'll do is, I'm going to solve this question with two methods. Okay. So let's start with the first method. Now here, what I am doing is, I'm putting sec x is equals to u. Okay, so let's sec x is equals to u. Okay, now I'll differentiate both the sides, so it would be sec x into 10x is equals to du by dx, or I can say dx is equals to sec x upon 10x. Okay, what I'll do is, I'll put the values back, so it would be, see, what I can do is, I can put sec 4x as sec cube x into sec x into 10x, right? Okay, and dx I can put as du upon sec x 10x, right? So this sec x and this 10x will get deducted, right? Finally, I can put sec cube x as u cube into du, right? So when I'll integrate this function, what I'll get is u raised to power 3 plus 1 upon 3 plus 1 plus c, that is equals to u raised to power 4 upon 4 plus c. I can put the value of u again, that is sec 4x upon 4 plus c. So this is the first method of doing this question. Now we'll try method number 2. Okay. Now in this, I'm supposing let 10x is equals to u. Fine. So when I'll differentiate both the sides, I'll get sec square x is equals to du by dx. Or I can say dx is equals to du upon sec square x. Fine. Now I'll substitute the values back here. Okay. So it would be c sec 4x into 10x. I'm putting the value of dx first, that is du upon sec square x. Okay. So these values will get deducted and it will be sec square x here. Okay. So now it would be sec square x into 10x. Now I can put sec square x equals to 1 plus 10 square x into 10x, right? So after multiplying this, what I'll get is integration of 10x plus 10 cube x into du. Okay. Now what I'll do is I'll put the values of 10x as u. Okay. So it would be u into du plus integration of u cube into du. Fine. Now I'll integrate both with respect to du. Okay. So both the functions I'll integrate. It would be u square upon 2 plus u raised to power 4 upon 4 plus the constant quantity. Okay. So the final value would be, I'll put u again as 10x, that is equals to 10 square x upon 2 plus 10 raised to power 4x upon 4 plus c. Okay. So you can solve this question by using any of the two methods, and both the methods are correct and both the answers are correct. Okay. So now let's move on to next question. Now in this question, I need to integrate x cube upon x square plus 1 whole cube dx. What I will do here is I will try to make the denominator term as simple as possible. So what I'll do is I'll suppose x square plus 1 is equals to u. Okay. Now I'll differentiate both the sides to get the value of dx. So let's do it. X square, it would be differentiation of x square is 2x is equals to du upon dx, right? And it means dx is equals to du upon 2x. Now I'll substitute the values back in the question. So it would be, I'm keeping x cube as it is, and for x square plus 1 I can put it as u cube. Now for dx I'll put du upon 2x. Okay. So 1x will get eliminated and it will be x square. Okay. Now what I'm doing is I'm taking the constant term outside the integration sign. So it would be x square upon u cube into du. Now I need to convert this x square in terms of u, right? Now I have x square plus 1 is equals to u. So x square is equals to u minus 1. It implies x square is equals to u minus 1. Okay. So I'll put this, instead of x square I'll write u minus 1. Okay. Now I'll distribute the denominator for both the terms. So it would be u upon u cube minus 1 upon u cube. Okay. So now it would be 1 upon u square du minus 1 upon 2 integration of 1 upon u cube du, or I can write it 1 upon 2 u raised to power minus 2 du and minus 1 upon 2 integration u raised to power minus 3 du. Now I need to integrate u raised to power minus 2 and u raised to power minus 3. Okay, I'll take this common again. What will be the integration here? U minus 2 plus 1 upon minus 2 plus 1. Okay, and for this it would be u raised to power minus 3 plus 1 upon minus 3 plus 1 and the constant term. Okay, so finally I would get u raised to power minus 1 upon minus 1 minus u raised to power minus 2 upon minus 2. So I can write it this way, minus 1 upon u and plus 1 upon 2u square plus c, okay, the constant term. Now in the next step, what I'm going to do is I'm going to substitute the value of u again, okay. So x square plus 1 and plus 1 upon 2 into x square plus 1 whole square plus c. Now this is an algebraic expression, so I'm going to solve it, okay. So after solving the algebraic expression, I would get minus 1 plus 2x square upon 4 into x square plus 1 to the power 2 plus c. So this is the required answer for question number 14. So let's move on to next question now. Now in this question, I need to integrate 1 plus 10x upon x plus log sec x into dx. What I am going to do is, I can put x plus log sec x as u. Fine. Now I'll differentiate both the side to get the value of dx. So it would be differentiation of x will give me 1. Now I'll first differentiate the log function. Okay, so log sec x would be 1 upon sec x. And now in the next step, I'm going to differentiate sec x. That is equals to sec x into 10x. So hope this is clear to you. This would give me du upon dx. Now both the terms will get deducted and I have got 1 plus 10x into dx is equals to du, right? So it implies that the value of dx is equals to du upon 1 plus 10x. Now I'll put these values in the question, okay? So it would be 1 plus 10x. Okay, I'm keeping 1 plus 10 as it is, okay? And instead of x plus log sec x, I'm putting u. Now I'm substituting the value of dx, that is equals to du upon 1 plus 10x. So see, 1 plus 10x and 1 plus 10x got deducted, and finally I'm left with integration of 1 upon u du. Okay, now we know that the integration of 1 upon x dx is equals to log x. Okay, similarly, integration of 1 upon u will give me log u plus c. Okay, so I'll substitute the value of u again. So it would be log x plus log sec x plus c. So this is the answer for question number 15. So let's move on to next question now. Now in this question, I need to integrate sec 4x into dx. See, we do have the direct integration formula for sec square x, that is equals to 10x. But we cannot integrate sec 4x directly. So what I can do here is, I can distribute sec 4x in this way. Sec square x into sec square x into dx. Now we have this identity 1 plus 10 square x is equals to sec square x. So I can put 1 sec square x as 1 plus 10 square x. Now what I'll do is I'll multiply. So it would become sec square x plus sec square x into 10 square x into dx. Okay, I'll distribute again this. So it would be integration of sec square x dx plus integration of sec square x and 10 square x dx. We do have the direct formula for integration of sec square x into dx, but we do not have the direct formula for sec square x and 10 square x dx. Okay, so what I am going to do is I'm going to use substitution method here. So what I'll do here is I'm doing it here. Okay, I have this sec square x 10 square x into dx. I can put 10x is equals to u. So what is the differentiation of 10x? I'll differentiate both the sides to get the value of dx. So the differentiation of 10x will give me sec square x, that is equals to du upon dx. Or finally I'll get the value of dx as du upon sec square x. Now I'll put the values back in the question. So it would be sec square x, 10 square x will change to u square, and dx du upon sec square x. So it will get eliminated, and finally I'm left with integration of u square into du. That is equals to u cube by 3 plus c. I have the value of u as 10x. Okay, so the final answer is 10 cube x upon 3 plus c. So now I'm going to write the final answer here. See, the integration of sec square x will give me 10x plus c. Okay, and the integration, we already have solved this. Integration of sec square x into 10 square x is 10 cube x upon 3 plus c. Now we have two c's, that means it's just a constant quantity. So we can write it as 1c. That is not a problem. Fine. So this is the answer for question number 16. So let's move on to next question now. Now in this question, I need to integrate sine into log x upon x into dx. Okay. So here what I can do is I can put log x is equals to u. Now I'll differentiate both the side to get the value of dx. So log x will give me 1 upon x, that is equals to du upon dx. Or I can say the value of dx is equals to x into du, right? Now I'll substitute these values back in the question. So I'll get sine. Now instead of log x, I can put log x as u. So it would be sine u. X I'm putting as it is. And for dx, I'm putting x into du. So x and x will get eliminated. And finally, I'm left with sine u du. So I need to integrate sine u. So we know the integration of sine x gives us minus cos x plus c. So similarly, the integration of sine u here will give us minus cos u plus c. Now I'll substitute the value of u again, that is log x. So it would be minus cos log x plus c. Okay, so this is the required answer for question number 17. Now in this question, I need to integrate cos x minus sin x upon 1 plus sin 2x into dx. Again, I need to work on my denominator term. But here in this question, substituting 1 plus 2x as u won't work, as it will not give us the required terms. So what I can do here is, we know we have this identity of sin square x plus cos square x is equals to 1. What I can do here is, I can put 1 as sin square x plus cos square x, and instead of sin 2x, I can put 2 sin x into cos x. Again, we have this identity of sin 2x is equals to 2 sin x cos x. Now, if you see here, we have formed another identity. That is, see, if this is a, then this is a square plus b square plus 2ab. That is a plus b whole square. So I can write this as sin x plus cos x whole square into dx. Now what I'll do is I'll substitute. Now I'll put sin x plus cos x is equals to u. Sorry. Now I'll differentiate both the side to get the value of dx. So sin x will give me cos x and cos x will give me minus sin x is equals to du upon dx. It implies the value of dx here is du upon cos x minus sin x. So I'm going to put the values back in the question. I'm keeping cos x minus sin x as it is for now. And for sin x plus cos x, I'm substituting u square, okay, into dx is du upon cos x minus sin x. So both the terms will get deduct and I'll get u raised to power minus 2 into du. Now I'll integrate this. I'll get u minus 2 plus 1 upon minus 2 plus 1 plus c. So finally I'll get u raised to power minus 1 upon minus 1 plus c, or I can write it minus 1 upon u plus c. Now I'll substitute the value of u again, that is I have u as sin x plus cos x. So minus 1 upon sin x plus cos x plus c. So this is the required answer for this question. Now in this question, I need to integrate 1 plus sin x upon 1 plus cos x into dx. So first I'm going to distribute the terms of numerator. Okay, so I'm going to write it as 1 upon 1 plus cos x into dx plus integration of sin x upon 1 plus cos x into dx. Now I'm going to perform integration for both the terms independently. So let's first solve for integration of 1 plus cos x into dx. What I can do here is I can rationalize this. So it would become, I'll multiply and divide by 1 minus cos x into dx. So it would be 1 minus cos x upon 1 minus cos square x into dx. Or I can write it as 1 minus cos x upon sine square x into dx. Right, we know that sine square x plus cos square x is equals to 1. Now again, I'm going to distribute the terms. So it would become 1 upon sine square x into dx minus cos x upon sine square x into dx. That is what I need to do is I need to find integration of 1 upon sine square x. That is equals to cosec square x dx minus integration of c. Here what I can do is I can take cos x upon sin x as one quantity. Right, so cos x upon sin x is what? Cot x. And then one sin x would be left. So I can write it as cosec x into dx. What is the integration of cosec square x? We know the integration of cosec square x is minus cot x minus what is integration of cot x? Integration of cot x and cosec x is equals to cosec x. So it would be, sorry, minus cosec x and plus c. So I'll get cosec x minus cot x plus c. Now I am going to integrate sin x upon 1 plus cos x. Let's do it. Here what I'll do is I'll assume let 1 plus cos x is equals to u. So I'll get, when I'll differentiate both the sides, I'll get minus sin x is equals to du by dx. Or I can say the value of dx is equals to du upon minus sin x. So I have less space here, so I'm going to write it directly now. So it would be, I'm keeping sin x as it is, and 1 plus cos x I'm going to put it as u. For dx I'm going to put du upon minus sin x. So both the terms will get deducted. I'm left with minus integration of 1 upon u du. Okay, so that is equals to minus log u plus c. What is u? U is 1 plus cos x. That is minus log 1 plus cos x. So this is my final answer. This term plus this term. That is equals to, so this is the final answer now, cosec x minus cot x minus log 1 plus cos x and plus the constant term. So this is the required answer for question number 19th. Now in this question, I need to integrate sine theta plus cos theta upon under root sine 2 theta into d theta. Now in these type of questions where mostly the numerator is somewhat like sine theta plus cos theta or sine theta minus cos theta and the denominator is sine 2 theta or under root 1 plus sine 2 theta, then we assume a variable in such a way that the derivative of that variable gives us the numerator. Now here, in order to get derivative as sine theta plus cos theta, what we can do is we can assume sine theta minus cos theta as u. Okay, so I'll put sine theta minus cos theta is equals to u. Now I'll differentiate both the sides to get the value of d theta. So sine theta will change into cos theta and minus cos theta will change into plus sine theta, right? This is the derivative of cos theta. Will give me du upon d theta. Or finally, I can say the value of d theta is equals to du upon cos theta plus sine theta. I'll substitute the values back in the question. I'm keeping sine theta plus cos theta as it is. Also, I'm keeping this also the same, sine 2 theta, because I don't have the value of sine 2 theta as of now. So, and d theta I'm keeping du upon cos theta plus sine theta. So both the terms will get deducted, and finally I have du upon under root sine 2 theta. Now I need to find this value. I need to find the value of under root sine 2 theta. So from here, I'll find the value of sine 2 theta. See, I have sine theta minus cos theta is equals to u. What I'm going to do is I'm going to take square on both the sides. So it would be sine square theta plus cos square theta minus 2 sine theta cos theta. So I've got the value of sine 2 theta here. We know that sine 2 theta is equals to 2 sine theta into cos theta. This is equals to u square. Also, we know sine square theta plus cos square theta is equals to 1. That means 1 minus, this would change into sine 2 theta, right? So I can write it directly, sine 2 theta is equals to u square. Or finally, I can say that the value of sine 2 theta is equals to 1 minus u square. Okay, now I'm going to put the value again. So it would be integration of du upon under root 1 minus u square. Also, we know that the integration of 1 upon under root 1 minus u square is equals to c. We know that integration of 1 upon 1 minus x square into dx gives us sine inverse x. So I'll apply the same formula here. It would give me sine inverse u plus c. Now I'll put the value of u. So it would be sine inverse. What is u? It is sine theta minus cos theta and plus c, the constant term. So this is the solution for question number 20. So I hope all the questions up till here are clear to you. If you have any doubts, you can post in the comment section below. Also, please like and subscribe my channel if you like my videos. Thanks for watching my video. Goodbye.